51. Y equals x over x plus 1. How many tangent lines to this curve pass through this point? At which points do these tangent lines touch the curve? Okay, so the first thing I notice is this is not on the curve. So when I plug 1 in, I get 1/2, not 2. So it's not on the curve. All right, something that might help you is if you make a quick sketch of the curve. It doesn't have to be extremely accurate, but I know that this is a rational function, okay, and -1 is a vertical asymptote, and the degree on top matches the degree on bottom. So if I took the limit as x goes infinity, I would have a horizontal asymptote at 1. Okay, so it's going to look something like this. Okay, now 1 comma 2 over 1 up 2 is right here. So this is going to glance off somewhere down here, it looks like, and somewhere over here. Okay, so this is the point 1 comma 2, and this is the point, if it was variable, it would be x comma x over x plus 1, but it's a specific point. So we're going to go a comma a over a plus 1. We're going to find out what the slope is of this line right here. Now we don't have to do both, because this point right here is also a comma a over a plus 1, right? Or maybe b comma some constant. Okay, so let's see what happens here. Let's go algebra 1 style first. A over a plus 1, subtract 2, all over a minus 1. Okay, that's the slope. Now, let's find the slope using calculus. The derivative of this using the quotient rule. Okay, let's find the components of this. U is x, u prime is 1, v is x plus 1, v prime is 1, and v squared is x plus 1 squared. Okay, so we go vu prime, x plus 1, subtract x, okay, all over x plus 1 squared. The x's cancel, and my derivative, dy dx, is equal to 1 over x plus 1 squared. Okay, the derivative is waiting for an input. Where do we want the derivative? We want it right here at a. So a, my slope here, is 1 over a plus 1 squared. Okay, so we're going to set these equal to each other. 1 over a plus 1 squared is equal to a over a plus 1 minus 2 all over a minus 1. Okay, that's a complex fraction. So we need to first of all write this as in a non-complex form. Okay, the way I'm going to do that is I'm going to say the common denominator on top here is a plus 1. So if I multiply the bottom by a plus 1, I have to multiply the top by a plus 1. Okay, let's start there. Okay, so on top I have a minus 2a minus 2 all over a plus 1 all over a minus 1 is equal to 1 over a plus 1 quantity squared. Alright, so there's several ways to take care of this. We could work the complex, divide by the, or multiply by the reciprocal. I think because we have a fraction here, a proportion, I'm going to go ahead and make this an a minus 1, cross product that like this. Okay, so the reason why I want to do this, I could go ahead and cross product like this, or I could make the common denominator a plus 1 squared by adding another a plus 1 here. And this simplifies to negative a minus 2. So I have this a minus 1 over a plus 1 quantity squared is equal to negative the fraction a plus 2 times a plus 1 over a plus 1 squared. Okay, being that the bottoms are equal to each other, the tops are therefore equal to each other. So we have this a minus 1, or let's go like, yeah, let's multiply this. Let's go negative a plus 1, so that's over here now, is equal to a squared plus 3a plus 2. Okay, so since the bottoms are equal to each other, the tops are equal to each other, so I'm just going to solve the tops now. I'm going to add a, I'm going to subtract 1, and we have this quadratic. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. A equals negative 4 plus or minus the square root of 16 minus 4 is 12 over 2. A equals negative 4 plus or minus, this is 4 times 3, so it's 2 squared to 3, all over 2. I can simplify because both of those I can distribute a divide by 2 through, so a equals negative 2 plus or minus the square root of 3. Those are my a's. So if we want the actual point, negative 2 plus the square root of 3, comma, something, and negative 2 minus the square root of 3, comma, something. And we're just going to substitute those back into a over a plus 1. So this would be negative 2 plus the square root of 3 all over negative 2 plus 1 would be negative 1 plus the square root of 3. And this one would be negative 2 minus the square root of 3 all over a negative 2 plus 1 would be a negative 1 minus the square root of 3. Those are my points